Okay, geometry class. Well, here we are online again, and we are going to do lesson 8.4, the second portion, because if you can remember on Thursday, we only did the first portion of the assignment. So today we're going to do day 2. So I am on, technically we're going to start here on page 9 of the notes that says special factoring patterns. Before we do that though, so this is the official start here, right here. I think it's page 9. I hope it's page 9 for you, but anyhow, it's the second portion of 8.4. But before we do that, let's do a little review here, because I do not think that we, hold on, I'm checking my mic, hold on. All right, hopefully that's better. Okay, I don't think we did all these. And so let's just do a review from the previous page, page 8 of the notes. And this is just factoring quadrilaterals. Now remember, of course, this is an equation. And so the first thing you do, we're going to do I and J here. I wonder if we did those in class. I don't remember which ones we did. We're just going to do them both. Okay, so the first thing we do when it's an equation, remember when there's that equal sign, you know you're going to tell me what x is. You're going to solve for x. You're not just going to factor, you're going to solve it. And your first step is to set it equal to 0. Okay, make sure it's in standard form, which it is, and then you're going to try to factor. So you make your 2 parentheses, 2 numbers that multiply to give me 2x squared. Well, the only options are to have a 2x and an x, and you multiply those together, you'll get your 2x squared. And then the other 2 numbers, here and here, those have to multiply to give me 3. So the only options is 3 times 1. But the question is, am I going to put the 3 here and the 1 there? Or am I going to put the 1 here and the 3 there? And you have to figure that one out. And so when you look at this, remember when you FOIL, let's do it first with the 3 and the 1. There we go. Okay, when you do that, you're going to take this times this number, and you get 2x. You're going to take 3 times x, and you get 3x. Remember, this plus sign right here says the signs are going to be the same. They're either both positive or both negative. But then this plus sign right here says that they both have to be positive. So what I have then is 2x plus 3x, and that does not equal 7x. So therefore, I know that this is not the correct factoring. So then I'll do it the other way. I put my 2x, my x, and I'm going to put the 3 here and the 1 there. The signs have to be positive, so I put those in. And that is factored. And if you check it, you do 2x times 3 and you get 6x. You do 1 times x and you get plus 1x, and that will give you your 7x. So we factored correctly. So now what we want to do, because it's an equation, is we want to solve it. And so we're going to set each one of these equal to 0. So that means 2x is a -1 and x is a -1/2. That's one of the answers. The other one comes from the second factor. So x is a -3. So there's my 2 answers for I. Then for J, again, it's an equation. Set it equal to 0. Factor it. And so with 6, we have a lot of options. So this 6, this 6 could be, I think we did this one. This one looks familiar. 3 times 2 or 6 times 1. And of course, this 6 could also be 3 times 2 or 6 times 1. And so we want to, first of all, we also notice there's a minus sign. So we know our signs will be different. And we know we're going to add to get a +5. So let's just try it. Let's do 6x and x. So I'm trying this first. And then I know that if I would put the 6 and 1 here, if I would put 6 here and 1 there, I will get a 0x or a 12x, neither of which I want. So I'm not going to put a 6 and 1 there. Also, if I put a 1 here and a 6 there, I would get a 36x, which is way too big because I only want 5x. So I'm going to cross that one. Well, wait a minute. I don't want to cross it out. I'm going to get rid of this being a 6x. That's what I want to get rid of. So I don't like this being 6x. Get rid of all that and that. And now I'm going to try it with the 3 and the 2. So I'll put a 3x and a 2x. If I would put a 3 here and a 2 here, so right here, when I go like this, I get 6x squared, which is what I want. And when I go like this, I get a 6, which is what I want. I need it to be negative though, so these signs will be different. And then I can check the inside stuff. Okay. And this one times this one gives me 9x. And the two little ones give me 4x, or I'm sorry, not little, but the two close in ones. And I need a positive 5x, so I need a positive 9x and a negative 4x, because 9x minus 4x will give me my 5x. And so then negative 2 times positive 3 will give me my negative 6. So there it is factored right there. This is just the checking, which you should always check. This would be a difficult problem because there's a lot of options, but you should still be able to tackle it. You just have to reason it out. All right, so once you get to that step, you're going to go down here and you're going to say, okay, if this factor times this factor equals 0, then 3x minus 2 is 0, or 2x plus 3 is 0. Which means 3x equals 2 and x is 2/3. Or here, 2x is negative 3 and x is negative 3/2. And there's your two answers. So that's just a little review on factoring. And now what we're going to do is we're going to look at some special factoring patterns. These are kind of nice because if you train yourself to recognize these patterns, then you have a very simple factoring job because they will always factor the same. So this first one is called the difference of squares. This is a very important factoring pattern. And so what it is when you, first of all, the word difference means subtraction, has to be subtraction, and squares are perfect squares. So for example, a squared minus b squared. Those are two perfect squares. Whatever a is, if you square it, you have a perfect square. And whatever b is, if you square it, you have a perfect square. So a squared minus b squared will always factor in this way. Always. Here's an example. If you have x squared minus 25. So x squared is a perfect square, 25 is a perfect square, and of course there must be a minus sign because it's the difference of squares. And that will always factor as the square root of the first one, which is x, minus the square root of the second one, and then the square root of the first one plus the square root of the second one, which means that is wrong. Oh my, x minus 5, x plus 5 would be the correct answer right there. Get rid of that. That's very bad. Okay, so let's look down here at example A real quick. When you look at that, it's a quadratic because x is being squared, so you know it's a quadratic. But you also should notice that this right here is really 9x squared, because 9 squared is 81, x squared is x squared. And then 1, of course, is 1 squared. So this is the difference of squares. So this will factor very simply as 9x minus 1, 9x plus 1. And there it is. Okay? We can look at B real quick. Now, this is not a quadratic because you have a cube. So technically, this is a cubic. But remember, your first rule of factoring is to take out what's in common. And they both have a 2 and an x. So if I take 2x out of the first term, I'm left with 4 2x squared. And if I take 2x out of the second term, I'm left with a minus 1. And now, look at that. That is a perfect square. I'm sorry, that's a difference of squares. So 4x squared is 2x squared. And of course, 1 is 1 squared. So this then will factor as, don't forget this 2x. So this whole thing factors, write down your 2x, and then you're going to say 2x minus 1 times 2x plus 1. And there it is factored. So don't forget that important rule of take out what's in common. All right, let's see if we can find one more to do. Let's do this one. This is also a difference of squares. X to the fourth, that's not a quadratic, that's a quartic because it has 4 x's in it. But this could be written as 2x squared squared minus 1 squared. So here's a perfect square, here's a perfect square, and we're subtracting. So it factors as 2x minus 1 times 2x plus 1. Okay? So anyhow, difference of squares, they're going to come up a lot, and they're really handy to know that pattern. Oh, here's one too. Here's one in an equation, example 2a. So you're going to solve these the same way. You're going to say, okay, 0 equals x squared minus 100. Now here you'd have a couple choices. If you remember, the first method we talked about was by square roots. And so you could say, well, I'm going to move the 100 to the other side. So you'd say 100 equals x squared, square root both sides, and so then x would equal plus or minus 10. That's a totally legit way to solve this problem. But you can also use the difference of squares. So this would factor as x minus 10, x plus 10. And then you use, this is now a factored quadrilateral, and so you're going to use your 0 formula, and you're going to say, well, then x minus 10 equals 0, so x equals 10. Or do this one, x plus 10 equals 0, so x equals a negative 10. And look at that, we end up with the same answers as right there. So you could factor it, or you could use square roots. Okay, let's go to the other special factoring pattern. This one, you know, might be a little bit more complicated, but please try to train yourself to see it, because it will really help you in the upcoming lessons and also next year. So these are called perfect square trinomials. So first of all, let's just talk about what that means. Perfect square, that means that there are going to be perfect squares in it. And then trinomials means there's 3 terms. That's what a trinomial is. So right here, we have a perfect square trinomial. We have 3 terms, 1, 2, 3. And so it's a trinomial, and the first term is a perfect square, and the last term is a perfect square. And the way you check this is to see if it's a perfect square trinomial, this middle term is very important. And what you do is you take your middle term, divide it. Well, let's do it this way. You take the square root of the first term, which is a, the square root of the second term, which is b, you multiply them together and then double it. And if you get this number, you have a perfect square trinomial, and it will factor like this. And notice here, if there's a plus sign here, it's because there was a plus sign there and there. And if there is a, oh my goodness, another typo. Hold on, let me fix that. This should say a minus. And if this is a minus, then this is a minus. So that's how you know your signs. So let's look at this little example here. So this is a trinomial. It's a quadratic. This, the square root of x squared is x. The square root of 9 is 3. So that's a perfect square. Well, we don't know if it's a perfect square trinomial, but we do know that this is a perfect square, and the last term is a perfect square. So then what I'm going to do is I'm going to multiply that 3 times the x, and then I'm going to double it, and I get 6x. And since that is the same as right there, it will factor like this, x plus 3 squared, and you're done. You don't have to try to figure it out. So here's another one. This is a perfect square, and this is a perfect square. So the square root of x squared is x. The square root of 25 is 5. If I multiply those together, I get 5x. And then I double it, and I get 10x. And that is this number. So therefore, it is a perfect square trinomial. It's a PST, perfect square trinomial. And those will always factor the same way as x minus 5 squared. The minus sign comes because of the minus sign. Okay, so let's look at C here. C is a quadratic. It's a trinomial. It might be a perfect square trinomial because this is a perfect square and this is a perfect square. So the square root of x squared is x. The square root of 1 is 1. If I multiply those together, I get 1x, and then I double it, and I will have 2x. And that is the same number as right there. So therefore, this is a perfect square trinomial, and this will factor as x plus 1 squared. This number goes in the first, this number goes in the second spot, the plus sign right there goes there. And then don't forget that little square. So another one right here. Let's see if this is a perfect square trinomial, f. So 4x squared, well, those are all perfect squares. So the square root of 4x squared is 2x. The square root of 1 is 1. So if I multiply those together, which means I do 2x times 1, and then double it, I have 4x. And that is the same as that number. So therefore, it is a perfect square trinomial. And how will it factor? Well, once you know it's a perfect square trinomial, it's pretty easy. You take the first one, which is 2x. You take the last one, which was the 1. This is a minus sign, therefore this is a minus sign. Put a parentheses and a little square symbol. Okay? Oh, we have a little problem in here that we didn't do. Got to get a little space. Okay, so let's do E real quick. So when I look at E, I notice there's a 4 in both terms, so I'm going to take that 4 out. And I'm left with x to the 4th minus 1. And although that's not a quadratic, it will still factor. So I'm going to say x to the 4th is really x squared squared. And 1, of course, is 1 squared. This is the difference of squares right there. A square minus a square. So it will factor then. I keep that 4, and I have x squared minus 1 and x squared plus 1. But now, something should jump out at you, hopefully, because that x squared minus 1 right here, this term, that is also the difference of squares. Perfect square minus perfect square. Therefore, this can factor more. So now I'm going to do, there's my 4, x squared minus 1 factors as x minus 1, x plus 1, and then here, this doesn't factor because it's not the difference of squares, so it's x squared plus 1, and there it is. All right, so let's go on to G. So for G, the first thing I notice, remember our first rule of factoring is take out what is common. So I can see that every term has a 3 and every term has an x. So I'm going to take those out, and I'm left with x squared plus 4x plus 4. And now when I look at that, this is a quadratic here, and this is a perfect square, and this is a perfect square. So the square root of x squared is x. The square root of 4 is 2. And if I multiply those together, I get a 2x, and then I double it, and I get my 4x. So check, this is the same number as that. This is a perfect square trinomial. So now I know how this factors. First thing, don't forget your 3x. So I have 3x times... X, put a 2 over here, you're going to square it, and this sign right there tells you it's a plus sign. And there it is, factored. It's in factored form. Okay, for H, first rule of factoring, take out what's common. Each term has a y, so I'm going to take a y out, and I'm left with 25x squared minus y squared. If I take one of the y's out, I only have 2 of them left, so there it is. And now that is a difference of squares. 25x squared is a perfect square. Y squared is a perfect square, so this will factor as 5x minus y, 5x plus y. And then we have one more here. I'm getting sick of orange. It's making me feel a little pukey. So let's go with green. All right. So when I look at this, what I notice is this is a perfect square. The square root of 81x squared would be 9x. This is a perfect square. The square root of 1 is 1. Now if I multiply those together, I get 9x, and then I double it. So I take 9x and I double it, and I get 18x, which is exactly what I have there. So it's a perfect square trinomial. So I know this is going to factor. This would be really a pain to factor because 81 is a big number, right? It might take a little time. I mean, maybe not. If you don't see that it's a perfect square trinomial, you could still factor it. But if you see that that is a perfect square trinomial, without much thought, you know you're going to go 9x plus 1 squared. That's how that factors. If you factored that, you would say, okay, it's 9x, 1, 1, plus, and look at there, those are the exact same things. 2 9x plus 1s, which is what this is, 2 9x plus 1s. Okay, now what we're going to do is we're going to take this now and apply it to equations. Oh my goodness, we will not be doing all these, but we'll do some of them. Okay, so here we are at B. I guess I don't need to erase. Draw. Okay, so first step is put in a 0. Okay, and now I want to factor this. Well, if it's a perfect square trinomial, then I can factor it super fast. And so, of course, x squared, the square root of x squared is x. The square root of 4 is 2. If I multiply those together, I get 2x. And if I double 2x, I get 4x. So this is a perfect square trinomial. So it's going to factor as x and a 2 over here. This minus sign goes right there, and there's squared. Now, since it's an equation, you know, technically what this means is I have 0 times x minus 2 times x minus 2. So the 0 factor would be x minus 2 equals 0, so x is 2. And again, I have 2 of those answers. That's okay to have 2 of the same answers. And so you can get this right here. You could say, well, x minus 2 is 0, so x is 2, but you have 2 of them. Now, as of right now, that's not a big deal. You can just say it one time, x equals 2. You don't have to say it 2 times. But next year, that's a pretty significant thing. So, okay, over here at C, this problem is just like A above it, which means you can either factor it or you can use square roots. So since we're practicing with factoring, let's do it that way. So I put a 0 in for y, and I have 9 minus x squared. And this is the difference of squares because it's a perfect square minus a perfect square. So you're going to say 0 equals 3 minus x and 3 plus x. I'll just cross you out for now. All right, and so now we use our 0 property. That means 3 minus x equals 0. So therefore 3 equals x, or 3 plus x equals 0. So therefore x is a negative 3. And we have our 2 answers for C. D, this is not in standard form, so let's first move it. Y equals x squared minus 16. Again, this problem could be solved with square roots or factoring, but we're going to practice factoring. This is the difference of squares. So we say 0 equals x minus 4, x plus 4. So therefore, we would say x minus 4 equals 0, or x plus 4 equals 0, in which case x would be 4, or x would be negative 4. And there's our two answers. So whenever you get the difference of squares, you know, it's a super easy factoring job. All right, F, not in standard form at all, so let's rewrite it. I'm going to move the 4 over. So that means I have y equals x squared minus 12x, and then I add 4 to that, and I get 36. So what I notice there, it's a trinomial, it's a quadratic trinomial, and this is a perfect square, and this is a perfect square. So let's see if it's the perfect square trinomial. The square root of x squared is x, the square root of 36 is 6, 6 times x is 6x, 6 times x is 6x, and then you have to double it, so you get 12x. And that is exactly this number here, yay. So it's a PST, perfect square trinomial. So then I know how it factors. This then will factor like this. 0 equals x minus 6 squared. So to solve that, I can say, well, then x minus 6 has to be 0 and x is 6. Now, this would be one of those times where you get 2 of those answers, and that's fine. You can give me both of them, or you can just say it once for now. G. Now, G could freak you out a little bit, but remember, that's not in standard form, and your first job is to get it in standard form, which means I'm going to move my y over. And so then I have x squared minus 81 equals y. And now, since I want to solve this, I put a 0 in for y, and I have x squared minus 81, and that's the difference of squares. So therefore, it'd be x minus 9 times x plus 9 equals 0, so x equals 9, or x equals a negative 9. So there are some equations using our special factoring patterns. So we have a few more problems. Notice in example 3, it says, if it cannot be factored, say so. So sometimes you won't be able to factor. So let's just start with A here. First of all, this is not a perfect square trinomial. Put a big X through that, because x squared is a perfect square, but 20 is not a perfect square, is it? So it's not a perfect square trinomial, so we're putting in a 0, and we're just going to try to factor. So we do x, x. We need two numbers that multiply to give me 20 and add to give me 9. Well, that would be a 5 and a 4. I know the signs are the same because I have a plus, and I know they have to be negative because of that. So this is x minus 4, x minus 5. And now I set it equal, each one equal to 0. And so my answers are that x could be 4 or x could be 5. There's the answers for that. For B, again, this is just a regular quadratic. It's not a perfect square trinomial because this is not a perfect square. So I'm going to go 0 equals, try to factor it, x times x. I need two numbers that multiply to give me 10. And this time, they're going to subtract to give me 3. I know it's subtracting because my signs are different. And so obviously 5 and 2 can subtract to give me 3. Since the 3 is negative, I need my biggest number to be negative. The other number is positive. Negative 5 times positive 2 will give me a negative 10. And so be sure to check your factoring so that you don't make little mistakes. X equals a negative 2. So we have two answers for that one. Next one. All right, this equation is nice because there is no constant. And if you can remember in class, I told you that when there's no plus c or extra number out there, all you're going to do is say 0 equals, what do they have in common? An x. You take an x out of both terms and you're left with x minus 6. And now you're already done factoring and you're ready for the 0 property. So that means this factor, x could be 0. or this factor, x minus 6 could be 0, in which case x would be 6. So there are my two answers. This one, D, this is the difference of squares. So you would put in 0, and you would factor this as x minus 7, x plus 7. If you want, you can FOIL that, and you will see that you will end up with x squared minus 49. That is a special factoring pattern. Therefore, x minus 7 is 0, so x is 7. Or x plus 7 is 0, so x is a negative 7. Just a little bonus here. Remember, you could have used square roots for that, where you'd say 0 equals x squared minus 49. You move the 49 over. You square root both sides. So plus or minus 7 is x. And look at that, exact same answers. Okay. E. First rule of factoring, take out what's in common. So I'm going to put in a 0. I am going to take out a 3, and I have x squared. Oh my goodness. What is 48 divided by 3? 16. There you go. And so, first of all, because notice here, there's no variable with that 3. I'm just going to divide both sides of my equation by 3. And then the 3's are gone, and 0 divided by 3 is still 0. So when there's not a variable, you can do that. Up here, when we did this problem, what we took out in common was a variable. You cannot divide out a variable, but you can divide out a whole number like 3. All right, so here we are. We are hopefully seeing that that is the difference of squares. So therefore, it's going to factor as 0 equals x minus 4, x plus 4. That's the difference of squares pattern. So therefore, x equals 4 or x equals a negative 4. There's our answer. All right, we get to F, and that's just a normal quadratic, but then I think, oh, wait a minute. This is a perfect square, and this is a perfect square. 64 is 8 squared. Of course, x squared is x squared. So if I multiply that x and that 8, I get 8x, and then I double it, I get 16x. Look at that. That's what I have there. So this is a perfect square trinomial. So it's going to factor as x, it's a plus sign, plus 8 squared. So then solving it, I just say x plus 8 equals 0, so x is a negative 8. Technically, there's 2 of them. You don't have to do it twice. But that would be the technical answer, but if you only give me 1, it's fine. Okay, next one. G. I see that they all have a 4 in common. So I'm going to say 0 equals 4 times 3x squared minus 7x minus 6. All right, I'm going to divide out that 4 just like I did in E. So I divide everything by 4. And I'm left with 0 equals 3x squared minus 7x minus 6. Notice you can only divide out a number when it's an equation equal to 0, and it's not a variable there. That's a normal number. Okay, so let's try to factor this. It's not a perfect square trinomial. 3 is not perfect square. 6 isn't perfect square, so we don't have any of that. Oh, wait a minute. Oh, silly, silly me. Look at that. Did any of you catch that? I didn't catch it. These are 2 constants. There's no x in there. So let's redo that. Delete that. Boom, boom, boom. Let's go down there. So if we have this problem, here's G. F of x equals 12x squared minus 28 minus 24. These are like terms. So therefore, f of x equals 12x squared. 28 minus 24 makes a negative 52, not 54, 52. And so then I'm going to say, okay, 0 equals, what do they have in common? A 4. and I have 3x squared minus 13. Divide out the 4. And so then I have 0 equals 3x squared minus 13. Now there is no factoring that can happen there, but you can still solve that using square roots. So I'm going to add 13 to both sides. I'm going to divide by 3, so 13 over 3 equals x squared, and then I square root both sides. So therefore, I have plus or minus the square root of 13 over the square root of 3 is going to equal x. But remember, right here, you can't have a radical in the bottom. So radical 13 over radical 3, you have to rationalize it. And so you get the square root of 39 over the square root of 9, which is 3. Plus or minus equals x, and there's your answer. That was probably a typo in the original problem, but there it is. There's no x there. Those are like terms. Okay, h. Nothing in common. Your only chance here is to try to factor it. So 3x would be 3x times x. I need some numbers that are multiplying to give me 12. So, you know, I could do 6 times 2. I can do 4 times 3. And of course, I can always do 12 times 1. I want to add to get a 5. So I'm going to try and start with my 4 and 3. I'm going to put a 4 here and a 3 there. I'm going to do that because I know I go this times this and I'll get a 9. This times this and I'll get a 4x. And together, those could make a 5 if I subtract them. I know from this minus sign, the signs are different, and the 5 says the 9 has to be positive, negative, and there we are factored. So then I'm going to say 3x minus 4 is 0, or x plus 3 is 0. In this case, 3x equals 4, and x is 4/3. Here, x equals a negative 3, and there are my 2 answers. How many more we got? 2 more. We will finish these. Okay, again, I is not a perfect square trinomial. This isn't a perfect square, and that's not a perfect square. So we're just going to try to factor it. I'm going to put a 4x here and an x there. If I do 4x times 2, I get 8x. And if that's a 2, this has to be a 1. The signs are the same, and they both have to be negative because I need my negative 8x and my negative 1 to make a negative 9. So then 4x minus 1 is 0, so 4x is 1, and x is 1/4. There's one answer. X minus 2 is 0, so x is 2, and there's the other answer. Last one. This looks really similar to something we already did, but that's okay. Okay, this has a perfect square. This has a perfect square. The square root of x squared is x. Square root of 81 is 9. Multiply those together, double it, and you have 18x. So it's a perfect square trinomial. So I know this is going to factor like x. The minus sign goes right here, minus 9 squared. So remember, technically that means I have x minus 9 times x minus 9. These two things mean the same thing. So therefore, x minus 9 is 0 and x is 9. There's your answer.